Hi guys, it's Abijah. Today we're doing 5.2 verifying identities. Um, yep, let's get into it. Here's Addison, say hi.
No!
Here's Redmond, say hi. Okay, here's Mr. Holloway.
Thank you. Before we start, should we do a quick song?
Yeah.
Happy birthday to you. Happy birthday to you. Happy birthday, Madam President. Happy birthday to you. Cool. All right. A year from today, you will get voter registration information from me. Cool. I assume you're 17. Okay. Happy birthday. Sweet. Okay. So I'm just going to go ahead and show everybody the elephant that's hiding here. When we say verifying identities, anybody know what we're leading into? I'm trying to make sure that what we say is true. Is there another way that I can say making sure that a mathematical statement is true? We're doing proofs. Is not correct, but proofs of these trigonometric identities is what we're really dealing with. Okay, you guys, thumbs up or thumbs down, where was your enjoyment of proof in geometry? Okay, so a bunch of liars, that's fair. What did you not like about proof?
The process.
The process.
It's okay, but you just keep going.
Okay, so we all love the fact that proof just kept going and going, and eventually you just kind of had to stumble your way through. Cool. Well, let's check it. On this section, we're just going to look and we're going to start right off with some basic guidelines. Just so you guys know, we are doing proofs. They are very different proofs than we did before, though. Before we did 2-column. If we have to switch back to 2-column, we will. We're going to do just singular proofs. I want us to annotate them, though, which is essentially what the 2-column forces us into, but I'm not going to require the formal A and B and B and C and C. These proofs are going to look different for us. Okay. So before we even start talking about these guidelines, an identity is true for which values? There's something that makes it true. And I'm trying to think of how I want to word this. For example, don't write this one down, but do we have an identity to say what tan theta is? It's sine theta over cosine theta. For which values of theta is this true? All of them. Every single value. An identity is something that's true no matter what you plug in. Now, there's a weird little part here where cosine could be 0 and it'd be wonky, but the identity still holds. Tangent is undefined when cosine is 0. We would get that out of this relationship. So a lot of this stuff, you guys just kind of have to take by trusting me, which I hope you don't think I get up here and lie to you guys about the math on a daily basis. Pretty sure I don't intentionally, or ever, I hope, but I'm sure I have misspoken. As we're looking at these, we are going to be proving these things. And we're just going to get some guidelines. Okay. The bummer part of this section is that if anybody is pretty reliant on checking your answers in the back of the book, every single answer in the back of the book is going to say answers may vary because everybody could take a different route through this problem. Earlier when I was talking about, that might have been a different class. We'll get there. Okay. Step 1, and these are in no particular, are they in order? Yeah, kind of. Step or guideline 1. We are going to work with one side. Work with one side only. And I'm going to put an asterisk next to this one because maybe we'll see a weird technique, but it means that we have equal signs that we're going to wind up proving that something equals something. We can't mess with both sides because then we're going to use a property of equality in trying to prove that something is equal, and we're just going in circles at that point. It's like me giving Addison a $20 bill and immediately saying, hey, can I borrow $20? She could hand it back to me, but we haven't really accomplished anything. Okay, so there's our first thing. We're going to work with one side. Now, this is going to feel counterintuitive. If we have the option of an easy side and a hard side, where's your gut want to start? What? Easy. Okay. If you have one side of the equation is really easy and nice looking and the other side is really ugly, which side are you naturally going to want to start with? Fight the urge. And I know it feels weird. We're going to start with the ugly side. Now, that is, again, subjective. but there's a reason that we do this, and we'll look at it. This is only guidance. You could start with the nice side, but the proofs get harder. You want to start with the uglier side, and we'll see that like work out today. Okay, step 2, or guideline 2 if we're thinking about it. We want a chance to be able to clean these things up as much as possible. And I wish I could, like, we could write a long, extensive list, but I don't think we need all of them. We should check for a few different things. When we get sine squared minus 1, and I'm going to write this up here in pink just to think. If this is a part of an expression, sine squared x minus 1, what immediately comes to your mind if we're trying to rewrite this? Pythagorean might be 1. What if I said that this was equal to, so you might think co-squared. Could I do this? And like, it may not be as natural because I've been just trying to get you guys to say Pythagorean anytime you see a trig squared, which I love that you did, but it could do something like this, right? So we're going to check for, and we're just going to list a few of them. Check for opportunities. Two, and we're going to have a colon because we have a few different things we're going to check for. We're going to check for, what would you call going from here to here? Factoring. That's what you said, right? Okay. Factoring. We may look for situations rather than factoring. We may need to add fractions. We may factor, we might add fractions and try to make a common denominator is what I mean by that. We might use other identities. We can't use the identity that we're proving, but if there's others that we know are true and we've already shown them to be true, they are fair game. You can use an identity to prove another identity. Okay, now are there more algebraic manipulations that we could possibly do? Like I could say GCF and different, like check for anything that's going to make the algebra feel nicer is really what we're saying here. Okay, when we're here, I'm going to cut this out because I said other identities. On number 3, we'll just go ahead and highlight it. This is what number 3 actually is. Compare or use other identities. And I'm going to give us a little bit of guidance, and you guys are actually going to help me work this out. Identities. And I'm going to call this pairings, which we've never used this language in here. But we're going to see if there's a possibility that we can use another identity or a convenient pairing. So, for example, if we're just going to do a couple EG of these pairings here. If I have a secant x, and this is an EG underneath. If I have secant x, and I'm just asking what is really convenient to multiply this by, are there some things that work better than others? Like, would sine work nicely here? Sine would be nice? Cosine would be nice. Why? Yeah, secants and cosines work really well together because this is 1 over cosine, and we're going to get stuff to divide out, right? Alternatively, and I'm going to write this nicer, we could use cosine x, and can I just put a couple different ones in here? So we're just looking for ones that pair up nicely. Does tangent pair up nicely with this? Why? So Pythagorean identity, for sure, if we get a tangent squared, is there another justification? So we would get sine over cosine, right? But if we think that out, even if we had tangent, and I did 1 over cosine times sine over cosine, what do we get in the denominator all of a sudden? Cosine times cosine would give me cosine squared. Should we be afraid of cosine squareds? No, we should welcome them because of whose identity? Okay, so yes, I'll take it. The Pythagorean identities, Pythagoras was the guy's name, but that's neither here nor there. Okay, secants pair up really nice with cosines and tangents. What do you think pairs up really nicely with cosecants? Sines and cotangents. So cosecant, and I'm just going to do this a little bit different. This pairs really nice with sines and cotangents. What pairs really nicely with sine? So tangent would pair nicely in certain, like for sure, because we get a sine squared. Like they will, honestly, they all kind of pair nicely together, but there's some that we should look at for like more than others. Sine and cosines pair really well. Same with the reason we could say that secants and cosines, because we get this 1 over sine and we can move to tangent and stuff. Look for the opportunity to pair stuff up that will cancel out. Okay, once we're there, if everything has failed up to here, and this is where it gets weird, if nothing above works, if 1 through 3 don't help. If we have a really ugly expression with a bunch of secants and cosecants and tangents and all that stuff, what do you think we might try if we don't want to have all the ugly cosecants, cotangents, tangents, and stuff? What have we been rewriting pretty much everything with every time? What's nicer than cosecants and cotangents and tangents? So if you had the option of dealing with tangent x, you could. Is there something nicer than tangent, though? What is it? Sine and cosine. Absolutely. If we can't do something nice before committing to, like, we've tried stuff, we can't figure it out, we're going to try to rewrite with sines and cosines. And cosines. Okay. And then step 5 is more not as math-centric as the other 4. No matter what. Do you guys remember how I graded proofs when you guys were in my geometry class? Every proof was worth 2 points every time. You got 1 point if it was completely correct. And where do you think the other point might have came from? So I did not take off points for QED, but I love that you said QED. Gosh, if only I could remember what QED stood for. Holy cow. Good on you. That's awesome. Quadrirot demonstratum is how we end the proof. But I would not take off points, just so you know. What do I expect everybody to do, even if you're not sure that you're going to get to the end? Try. Literally the most important piece is going to be try something. And I'm going to do this a little bit differently. I want you to try again. And if you've never heard this saying, inevitably, everybody in here, no matter whether you're like, oh my gosh, this stuff is so easy and I have it, or if you're like, oh my gosh, this stuff is so hard, I'm struggling, you're going to be wrong. Everybody in here will be wrong. I will probably be wrong on the board. As long as you try something, pretty low chance that you're going to pick something that doesn't work. If it gets uglier and uglier as you go, we're going to just agree to do something here that's going to feel unnatural. How many of you guys do work in pencil? When you make mistakes, what is your first thing you typically do? We're not going to erase through the section. Like, if it makes your notes ugly, I'm okay with it, and I need you to be okay with it. Because when you erase something that you tried and didn't work, it's like it never happened. I want you guys to be able to look at your notes and say, holy cow, I tried this and it failed, and we tried something else. We will all get stuck and we'll have to go back to the beginning. Don't bother wasting the time to erase, and don't erase the mistakes because we need them. All right. Always try something. Shall we do a couple proofs? Okay. So, as we're jumping into these, let's just see what we have here. Everything beyond this point is going to be like all example, which is awesome. We're going to do one here, and then we're going to do a few on the board. Okay. So, should we just try one on, you know what? Scratch that. We're going to just try this now. We're going to count off. We have 12 of you. That's 4 groups of 3. And check it out, Davian. We're going to skip count here. I'm starting with Davian, then I'm going to go to Redmond. Davian 1, Red 2, Abijah 3, Addison 4. 5, nope, we're going to go 1 again. Sorry, Aisha 1, Basil 2, Krina 3, Lay 4, Matilda 1, Casey 2, Dolan 3, Christina 4. Okay, 1s up here behind this board. 2s on the whiteboard between the screens. 3s on the big whiteboard. 4s behind Miss Sweet. There's an extra eraser over here. Nothing. There's an extra eraser on this front board. I'm going to put a few problems up here. Is it okay if you struggle?
I thought you were gonna make us do that.
I don't think you even know that symbol. I'm pretty sure you don't.
Like, what is that slide?
I'm pretty sure you don't. But yes, absolutely, you can erase. And I'm going to walk around here. Good. I think. So 100% got this idea from Jarvis. Like, definitely. All right. So I will work this proof also. I'm going to freeze my screen here. I'm going to work it on the board, and we're going to see different techniques. Remember the rules. Whoever's holding the marker, your job is to write, but what can't you do? You cannot speak. So if you are feeling really uncomfortable with what we're about to do, I would volunteer to say, hey, can I write this problem? If that's what I would suggest. Now, you can ask me questions, but I won't answer. When you guys are going to be doing the same problem, who can you ask? Like, let's say you guys are struggling. Who could you ask? Yeah, you can ask you guys. You can step back. You can look at other groups' work. I'm cool with it. Okay, does everybody have a marker, or one person in your group have a marker? All right, so I'm going to read you an identity without writing it first. I'm going to see if you guys can write it down just for me reading it. All right, I'm going to wait till we're ready. Okay, we are trying to prove the following. I want us to verify that 2 cosecant squared beta. Two cosecant squared beta. We would have gotten a very different. It's a B with a tail. Okay, I'm going to make a claim. This is equal to the sum of 2 different fractions, which is what's coming up. And I'm going to pause your guys' screen so that you don't have to write over the words. Okay, this is equal to, and I can come write it for you, Hazel, if you need me to. 1 divided by 1 minus cos beta. 1 divided by 1 minus the cosine of beta. Love it. Beta, you're using theta, that's okay, don't change it. I've been saying beta, but that's okay. Beta, all right. Plus 1 over 1 plus the cosine of beta. Okay, I'm going to keep these guidelines up on the board. I want you to follow them to a T, as well as best you can. Cool. Sweet. I want you guys to try this. Do it to it. Nope, wrong thing. Do you need a different one? Yeah, I got you. You about got T-boned when you stepped back out there into the intersection without looking. Lay on the desk behind you, Kim. I need to.
Oh no, the top would also just be. It would just be 2.